Okay, so this is an example of line integrals of vector fields in the plane, so 2D. So here's an integral where the vector field is expressed this way. So I think this is not what you are used to see in your lecture notes, but just in case this notation pops up in your homework, I want you to be familiar with that. So what you're probably used to see is f dot with dr, and these are all like vectors. And what's even more computationally useful is the following notation. So we can rewrite this. I'll kind of just skip the arrows on top. So what's even more useful is the notation f dot with r prime of t dt. Right, so it makes sense. We're just kind of rewriting the dr as r prime t dt. So then if we use this formula, then so this dt will remind you that the variable now is t. So, but the f, we see that the variables is x and y, so which means we need to kind of replace the x and y by things about t, right? So this is actually x in terms of t and y in terms of t. So then maybe one more prep work before we, I think we can do this in one step. So now everything is about t. So t is between 1 and 2. And then f, we said we should replace everything by t. So x is now t squared. Y is now 3t squared. And then you need to divide by, x squared plus y squared, which is t fourths plus y squared is 9t to the fourth to the power 3 over 2. So that's this f, replacing everything by this new parameter t. And according to the formula, we dot with r prime. So what is r prime? R prime is just, well, we're given r, so then r prime is just taking component-wise derivative. So t squared derivative is 2t, 3t squared derivative is 6t, and then dt. So that's the setup. And then I'm gonna just skip the kind of the algebra. So the final answer will be 3 square root of 10 divided by 40. Okay. So let's do an exercise that goes along with this. So it's formally kind of the same thing, right? The format is really similar. So like I said, if you're not comfortable with this notation, it's just what you see in class is f dot dr, and computationally speaking, it's the same as f dot with r prime t dt. And then you have some, you have the range for t here. So that means now everything is in t, and then so we just replace x and y here by, this is x, this is y, right? So then x comma y now becomes, we just copy that in this case. So 4t squared, and then dot with r prime. So r prime, so it's component-wise derivative. So derivative of 4t is 4, derivative of t squared is 2t. And then dt, t is from 0 to 1. So that's also not not bad either. So, and then I should give you the solution of this is 17/2. So you should work this out yourself. The algebra, it's good practice. Okay.